写出来，擦亮。1+2，对了吧？ 你可以给它算这个算。
Okay, so far so good.
I got a different answer.
You got a different answer?
It's 3 plus 2.
Maybe
Did I do my math
On
wrong?
the second row.
4, 5, 5.
So 3. So 3 times minus 1, 0 times 2. So this should be minus. Is this what you're talking about?
No, the next
No.
row. So the next one was like -1 times 4 plus 2 times
Minus 4.
Yes.
1 times 4 is
The minus 4. Minus 4. Yeah.
So that's
Minus 4. The last one is 5.
Oh, that's a 0.
Yeah.
Okay.
So
The
5.
next one is 5.
It's 5. The next one is 5.
Okay.
Huh?
Oh, 1 plus 4. Yes, 5. Okay.
可以不一样，可以一样。
I passed arithmetic.
Those tests on Canvas.
That's all right. Okay, so this one gets a little trickier, right? So right, we're using Kirchhoff's, right, conservation of current and conservation of voltage. So if we start with current and start with the nodes, so if we say at Q, we've got what? We got I1 minus I2 minus I3 equals 0. At P, we've got what? Minus I1 plus I2 plus I3 equals 0. Then we're going to do conservation of voltage, so we're going to do the loops. And if we do the left loop, let's see, what do we got? So E equals IR. So we're going to have what? I1, R1, I2, R2, and that's going to equal, well, these are both going in the same direction, so E1 plus E2, right? And if we do the loop on the right, let's see, we've got I3 and R3 plus I2, oops, and R2, and this one just equals E2, right? Does that make sense? Questions? And that's, all you're doing is just setting up the equation. Now, again, remember we talked about being overdetermined. We got 4 equations and 3 unknowns, because our 3 unknowns are the i's. But if you look at this, right, if I subtract I to the other side, it's I2 plus I3. If I subtract these to the other side, I1. So these essentially equal the same thing, so we could take one of them away if we were actually solving.
Can you just quickly go through the sign convention, how you got negative or positive?
So for the nodes, right? If we're going in, we're saying that's positive. If we're going out, we're saying it's negative. You can say it the other way, it doesn't matter, just as long as you're consistent with all your nodes. It's just a convention.
What about the E's, the batteries?
We're going, well, if I had numbers, this would be, whatever, 90 volts plus 40 volts, or 5 volts plus 2 volts, or whatever number that we're using. You don't have negative voltage, so at least I don't think so. So when we did that, you can also review the example problem that I did for one of the lectures. I don't remember which one, but we went through one that was kind of like that. It had numbers in it. This one doesn't have numbers, it's just.
So I read on the test, not an EE for a reason.
Not a what?
Not an EE for a reason.
Well, I'm not an EE either, but.
It's just a nightmare.
Well, but I mean, just setting up the equations, that's not hard. That's all you have to do. Not having to solve anything. Just got to set up the equation. So that should be okay. So let's try the next one. Right, so we got some force here. Element 1, element 2. Right, so we're just writing out what the structure stiffness matrix is. So see if I can get through this without messing it up. And then minus. This is going to become what? Okay. Okay, so then it's going to become. So that's your stiffness matrix, right? We haven't taken into account any boundary conditions or forces or anything. So the next one, we'll start out with okay, so this time we're looking for the final equation. So we have to look at our boundary conditions. So, you know, this goes to 0. We don't have a force at 0. All of these are going to go to 0. Let's see, yep, F2 is 0. That'll go to 0 because it doesn't move at 1. So what we should have left is K1 plus K2, K2 equals 0, right? K2 U2 plus K, this is a minus, K3 equals F, whatever's at F,
Yep.
right? F3,
Absolutely.
right? So that's our final equation, and all we need now are spring constants and the force. If we can figure out, whoops, I'm missing a term. K2U3 here equals 0. There we go. Now we got it right. Okay. So then we have K1 equals 100 pound-inches, K2 equals 200, F equals pounds. This is our equation. You know, what's my displacement? We're going to have 100 plus 200 is 150, right? So U is 150 divided by 300 equals 0.5. Okay, does that make sense? And let's see, so true, false. Today, most FEA programs define 2D elements as quadrilaterals. True. The modulus of expandability is an important material characteristic in FEA.
Is that the same as the modulus of elasticity?
Nope, it's the modulus of expandability.
So is that false?
So that would be false. No such thing as a modulus of expandability. Okay, so one of the assumptions made when we use a truss element in a model is The A, the connections can resist the moment. Well, that's false. B, the element can be subdivided. That's false. C, there's no kinematic collapse. That's true. And D, cross-sectional changes are allowed between connections. That's false, right? So answer is C. When analyzing our models, the pretty pictures are always assumed to be A,
D, it's gotta be D.
colorful, B, wrong, C, right, D, Picasso. All of the above? No. The answer is B. You're always wrong.